Hello everyone. Welcome to another interesting session of my project ideas. Today, we are going to begin the second topic of the chapter 2 of the DSA course, that is palindrome numbers. So, I guess you must know what are palindrome numbers, how to reverse a number, and how to check whether it's a palindrome number. So, hoping and with a positive note, let's begin today's session. So, what are the range limitations of the algorithm in the palindrome numbers? So the method is suitable for numbers with fewer digits than 10 to the power 18. See, 10 to the power 18 is also not a very small range, right? So there is a limitation that up to 10 to the power 18, up to that number only you are able to like check whether the number is palindrome or not. Numbers beyond this that have more than 10 to the power 18 digits have to be represented by a long int in most programming languages. Okay, so if you are in using a number that is greater than 10 to the power 18, no worries, write long int. This is a variable declaration, like if when you are declaring a variable, suppose number 10, so you are storing it in integer. Suppose there is another number which is in in not in the range of integer, then you're writing it long. So if something is more than 10 to the power 18, just write it as long int, variable description, declaration. Okay. So what are palindrome numbers? See here. If you do not know, no worries. Just have a look here. See 1, 2, 3, 2, 1. Suppose it's a number. When you reverse it, what do you get? 1, 2, 3, 2, 1. So if the current number and the reversed number are equal, then they are called palindrome numbers. See here, 1, 2, 3, 2. When you reverse, what do you get? 2, 3, 2, 1. So these two numbers are not equivalent. Hence, they are not palindrome. Okay. So what are the approach to find out whether a number is palindrome or not? First, convert the number into a string or manipulate it as a number to reverse its digits. So what do you do? What do we do? The basic thing is we try to reverse the number. And after reversing the number, we check whether it is equivalent to the current number or not. If they are equivalent, then they are palindrome. Then you compare the reverse digits to the original number. If the reversed number is same as the original number, then it is palindrome, which I have already said you. And if not, the number is not palindrome. Easy. So guys, in the PPT section, we saw what are palindrome numbers. How do we basically code for palindrome numbers? How do we write the algorithm? Coding means like figuring out the algorithm. You got to know what are palindrome numbers. Now what are we going to do is we are going to really code the algorithm which we discussed in the PPT section, and we are going to write it down. So some of you might have already figured out how to write it. So you can pause the video and you can write the code by yourselves. Others, if you do not know or if you did not get the point, no worries. Just be with me throughout the writing section. Okay. And do not forget about the time complexity and space complexity, which we saw in the PPT section, because that is what in that time complexity and space complexity we are gonna write this code. Okay. So gear up and let's write. So first, definition of the function. Check palindrome. Let's put a parameter n, put the colon, get down. Then let's declare a variable called reverse, and we have initialized it as 0. Then a temporary variable to store the number, because why did we just store the number in another variable? You might think it is absurd, but no. Well, we are going to find out the reverse of a number. We are going to reduce that number. Like we are going to first, what we'll do? We'll take the remainder. We will eradicate the remainder from the number. Like from if the number is 123, first we are going to take the number 3 out. So it will be 12. Then again we are going to take the number 2. We are going to make it 32. Then we are going to make it 321. So the number is gonna change. The number is gonna reduce. That's why to check it, the reverse number and the actual number, we need to have the actual number stored somewhere else. That's why we have taken the variable temp. Okay. Now let's write the code. While temp is not equal to 0. This is just basically to find out the reverse of a number. Okay, so this is the algorithm to find out the reverse of a number. So let's have variable reverse is equal to, so this is the formula, reverse into 10 plus temp mod 10. So what does temp mod 10 basically do? Suppose the number is 123. So temp mod 10 basically gives a remainder. So 123 if you divide by 10, what do you get? You get the quotient as 12. So when you first divide 123 by 10, you get, what do you get the quotient? You get the quotient as 12 and the remainder is 3. So this temp mod 10 gives a remainder 3. That you need to add with reverse multiplied by 10. So the reverse, and that needs to be stored again in the reverse variable. So the values are changing. So 123, first you got remainder 3 added to reverse into 10. What is reverse into 10? 0 into 10 is 0. So 0 plus 3, 3. So first you got the number 3 in reverse. In the next iteration, you will get the number as 32. In the next iteration, you will get the number as 321. Again, when you divide, let's write down the next line, then you will get to know. Then what we are going to do is we are going to have the integer division. Temp equal to temp integer divide 10. So here what happens? The variable 10 is reduced. So after each iteration, one digit is eradicated from the number. So when the temp will be equal to 0, you will be getting out of the loop. So here, according to our example, 123 has 3 digits. So after 3 iterations, you will be getting out of the loop. Got it? Now let me put a number. Say I said 123. Now we have to check whether the reverse number is same as the actual number or not. So we are gonna do that. Check palindrome. The parameter is n double equal to 1. Then we have to print what? Print yes. What is the meaning of this conditional statement? This means that you are gonna check whether your palindrome number, you are getting the number that is palindrome or not. So what happens there is, if your reverse number and the actual number are same, suppose 111, the reverse of that number is also 111. So if these two are same, you get the answer yes, or else no. Let's write that also. Print no. Got it? Let me save it. Let's run it. Did I did something wrong here? Let me check the code. Okay. I forgot the return statement. That's why I'm not getting the answer. So return reverse. I told you this, but I forgot to write. Okay. So this basically checks whether your reverse is equal to your number or not. Now let's run. Now I have the indentation is also incorrect, guys. I have done the indentation error here. So you need to be very careful about it. Well, it's really hard. The indentation part is really hard. Now let's run it again. So it says no. Let me clear the terminal for you and let's run it again for a separate number. Say 111. Let's run it. It says yes. So I hope it was understandable. I hope you understood the palindrome number concept. I hope you understood the coding. And for now, let's wrap up this session. Until then, stay tuned. Keep learning, keep coding, and keep exploring. Thank you guys. Have a great day ahead.